In this diagram, oval A right here represents some integer solutions. And remember the word integers, that means positive and negative whole numbers. So like -3, -2, -1, 0, 1, 2, 3. Those are all integers, but no decimals or fractions. So oval A represents some integer solutions. So anything that's inside of this is a solution to x is less than 10. All right. And so let's look at these. -1, yeah, that's less. -4, yeah. -17, 1, 2, 7, 9. Yes, those are numbers that are all less than 10, okay? Oval B represents some other integer solutions that of x when x is greater than 0. Okay, so let's look at these numbers. 1, 2, yeah, that's greater than 0. 7 and 9 are both greater, and all of these numbers are greater than 0 as well. So everything in this circle is greater than 0. The overlapping region, you see where both of them combine, is right here. This is where the two circles overlap, and pink and yellow make orange. Okay. The overlapping region represents the numbers that belong in both ovals. So see, these numbers are in this oval B and oval A. That means those numbers are solutions of both x is less than 10 and x is greater than 0. So look at this. 1, yes, it's less than 10 and it's greater than 0. So this is in both of the circles. What about 2? Yes, 2 is less than 10 and it's greater than 0. 7, yes, less than 10 and greater than 0. And lastly, 9 is less than 10 and greater than 0. So, you can graph the solutions of a compound inequality involving and by using the idea of an overlapping region. The overlapping region is called the intersection. It's where both of these circles intersect, okay? It's the solutions that fit both A and B. So the overlapping region is called the intersection and shows the numbers that are the solutions of both inequalities. So let's see here. X, we had, what did we have? X is less than 10. So if we were to graph that, we'd have an open circle at 10, and then X is less, so it would represent all of these solutions. Do you see here's the number line down here? Now the other one we had, what was that? X is greater than 0. So if we were to graph that one, we would go to 0. It's going to be an open circle, and x is greater than 0. Here's 0 right here. So it's going to be all these numbers here. Now when we look, what are all the solutions they have in common? Well, there's nothing here, nothing here, nothing here. But look, right here, the solutions are common with this graph and this graph. So that means they start at 0, and they're both in common, both in common, both in common, both in common until right here. You see now after this, these aren't solutions. So it's both in common all the way to right here. Now it's going to be an open circle on both sides because this is an open circle and that's an open circle. So the answers, the solutions have to be able to fit this this graph and this graph, okay? So like a solution like this isn't a solution here. It's a solution here, but it's not one here. So it wouldn't be a solution of both of these. What about over here? We would have a solution here, but not a solution here. So it would not be a solution to both. So only the solutions to both are the ones where they both have solutions. And then that is what the graph looks like. Now, this section is all about and problems and or problems. So what you had before is you had two inequalities, and then those two inequalities are going to come to one through either an and or an or. So graphically, do you see what we had down here? we had something like this. Anything that looks like this or any variation of that, that's going to be an and problem. And graphically, whenever you have something of the shape here, something like that, that is always going to be the shape of an or problem, okay? So you really have to know the difference between and or. Now the solutions for and are something like this, like it would be for this, right? It was, x was, what was x? It was it was greater than 0. So that was the smallest value. The smallest value is 0. And then it is less than 10. So that is how you write a compound and inequality. And the cool thing about this is it's actually made up from 2 inequalities. The first one would be the x is greater than 0, and then the second one is x is less than 10. And so when you combine those two together, you get a picture that's somewhat like this. Well, it would have been an open circle. We'll make it like that. And then that would be like that. And then you get a statement like this. Whenever you deal with ors, you'll look at that example the next time. So let's just look at this again. This is a table where we have a lot of different inequalities, and this is really where 2 inequalities become 1 compound inequality. So if you have x is greater than 2 and x is less than 6, that means that the solutions are all real numbers greater than 2 and less than 6. And look, there's our and picture right there. You notice you'd have both in open circles at 2 and 6. And then this is what you do. This is how you write it. You write the smallest value here, 2, and then the biggest value here, 6, and x is in the middle. So you can say x is greater than 2 and x is less than 6. So this is the compound inequality, and this is how you would graph it. So it's good to know what the compound inequality looks like, and it's really important to know what that graph shape looks like. So you start with the smallest value, write it here, you write the biggest value there, and you put x in the middle, all right? Now let's look at a different one. So here, it's pretty much the same thing. We have 2 inequalities that combine into 1 compound inequality. So we have the solutions, all real numbers greater than or equal to 2 and less than or equal to 6. So those are the solutions. That's how you write that. Well, it's the same thing. You write the smaller number here, the bigger number here, right, with x in the middle, except this time we're using that x can equal to and it can equal 6. So we go ahead and put those greater than or equal to or less than or equal to, okay? And notice it's that same shape, smaller number, bigger number, x in the middle, and here is that and shape once again. Okay, let's look at the other ones. This says x is less than 2, right? But when you talk about the solutions, they want you to say all real numbers. So instead of saying x, we would say all real numbers less than 2 or greater than 6, okay? So notice this compound inequality, it really just states both. Oh, I should have used a different color. That's okay. Except the smaller values are here and then the bigger values are there, and they're both separated by or. But you really have to make sure that you say the word or. You didn't really have to say the word. You didn't have to write the word and here. You just kind of said it. X is greater than 2 and less than 6. But here you have to write it. You have to write the word or for it to be right on your homework and quizzes and tests and all those types of things. So when we graph it, we use a open circle and we go to 2, right? And x is less than 2, so it's all of those solutions this way, or x is greater than 6, we have an open circle, which is going this way. And if you see that, there's that or shape. Okay, so anything looks like that, you're going to have an or. You're going to write the smaller values here, then you're going to write the word or, and then the bigger values right there. Okay, let's look at this one here. We had x is less than or equal to 2, but when you talk about the solutions, they want to say all real numbers less than or equal to 2, or x is greater than or equal to 6. So the only thing that's difference between these two is that we have that greater than or equal to, right? So we're going to have a closed circle in our picture over here. Remember, you have to write the word or, Here's the solution. That's what it looks like whenever there's an OR, and every OR has a picture that looks something like this type of shape. All right, let's go ahead and get started with a few examples. So here we go with example 2A. So we're going to solve the compound inequality and graph the solutions. What does this look like? Well, this kind of looks like an and problem, right? And I love these. These are so fun, okay? Compound inequalities. I'll give it to you. It looks a little scary. Yeah, it looks a little scary to me too. Okay, and I remember the first time I did these, and whenever I saw these compound inequalities, I was like, oh my gosh, what's going on? This is so scary. But what you need to know is it's really just two inequalities put together as one thing. And so everything that you do when you solve inequalities with just one inequality, you just do the same thing. Like, okay, so if you had -5 right here, so you had x plus 1 is greater than -5, what would you do to get x by itself? Well, it's like you did everything you did with equations, right? So we would try to get x by itself by using the inverse operation of +1, which would just be -1, and we just do it to both sides. All right, so we'd have -6 is less than x, or x is greater than -6. That wasn't that bad, right? So that's one of the inequalities right there. X plus 1 is greater than -5. But there's another inequality there as well. It's this one. X plus 1 is less than 2. That is the second inequality that's represented. Well, what would we do if we want to get x by itself? Well, you would just subtract 1. Wow, see how I did the same thing for both? That was my first step. That cancels. I'm left with x is less than 1. All right? So you can do that. So this is the cool thing I love. Whenever you're doing compound inequalities, like over here, there was like, how many sides were there to the inequality? There was one side and two sides, right? And then how many sides are here? One side and two sides. Well, this is actually the same side, right? So we really have 1, 2, 3 sides. So what I love to do is just draw a line straight down here. And this is one side, two sides, and 3 sides. And then I just go like this. How do I get x by itself? I have to subtract 1. Well, I do it from this side, and this side, just like we did in the equation, right? We subtracted 1 to everything. And then we go -5 minus 1 is -6. And then that cancels. We're left with x is less than 2 minus 1 is 1. So I'm going to rewrite that because it kind of looks messed up. And then I have my and answer. X is greater than -6 and less than 1. And now we just have to graph it. So we're going to go to -6. It's going to be an open circle. Then we're going to go to 1, which is halfway between 2 and 0. And that's an open circle too. And x is greater than -6 and less than -1. So it's just all the numbers in between. So that's it. All right, let's look at the next example. Ooh, this one looks a little bit more complicated, but I know that we can do this. Okay, so those inequality signs, you just draw a line straight down, and we got to get x by itself. So the first thing we're going to do is it would just be like, what would we do if we had this? Well, the first thing we would do is add 1. That's the same thing here. When you're getting x by itself, you have to get rid of this and use the inverse operation of subtraction, which would be addition. So we're going to add 1 to both sides. I mean, not both sides, all 3 sides. 8 plus 1 is 9. And then that cancels, so we're just left with 3x. And then 11 plus 1 is 12. I just remember being so intimidated, but once I figured this out, I was like, oh my gosh, this is like the easiest thing in the world. And then we just need to get x by itself, so it's 3 times x, right? What's the inverse operation of multiplication? Division. Then we just divide by 3 to 3 sides. And then 9 divided by 3 is 3. 3 divided by 3 is 1. 1 times x is just x. And then 12 divided by 3 is 4. And there is our and answer. And notice how it just resembles this, right? You have the smaller number, bigger number in the middle. So then we're just going to graph it. So we go to 3, and there is a, open circle. And then we go to 4, and it's going to be a closed circle. and then x is greater than 3 and less than or equal to 4. So it's everything in between these two numbers. And look at that and shape. Oh, it's such a cute little and shape. Look at that and shape. Oh, they're so cute. All right. Now it is your turn, ladies and gentlemen, to check it out. For example, 2a and 2b. So here's my friend, the pause dragon, reminding you it's time to pause your device, work out those problems, and graph them. And then when you get done, press play, and we'll talk about the solutions. See you in a little bit. All right, let's see how you did. So I'm going to drop this into my 3 sides of my inequality. We want to get x by itself, so we're going to add 10. Negative 9 plus 10 would be 1. X, that cancels, and negative 5 plus 10 would be 5. Great. There's the answer. If you got that one right, awesome. Now we just need to graph it. So we need to open circle at 1, open circle at 5, and x is everything in between. X is greater than 1 and less than 5. All right, let's look at the next one and see how you did. So the first thing I'm gonna do is just draw those lines down. I'm just gonna get n by itself, so we have to do the inverse operation of a positive 5, which would be a negative 5 to all 3 sides. Negative 4 minus 5 would be negative 9. And 11 minus 5 would be 6. Perfect. And then we just get n by itself. So we have to do the inverse operation of multiplication, which is division to all 3 sides. Negative 9 divided by 3 would be a negative 3. And 6 divided by 3 is 2. So there is our answer right there. If you got that one right, great. Let's go ahead and what are we going to do? Graph it. Yes, we are. So we have a closed circle at 3, negative 3, and then an open circle at 2, and n is greater than negative 3, yet it is less than 2. So n is just all of these numbers in between. So if you got all of that right, you did a wonderful job, and we will see you next time. Goodbye.